Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic, we're going to discuss geometric interpretations of real 2- and 3-dimensional vectors. So in this topic, we will look at geometric interpretations of 2-dimensional vectors and consider geometric interpretations of 3-dimensional vectors, where we are going to have to introduce the right-hand rule. Now, real 2-dimensional vectors can be interpreted as a point on the plane. Generally, the axes are labeled x and y. The 2D vector is interpreted as a coordinate in the xy plane, so the vector v has a first coordinate x and a second coordinate y. The first coordinate corresponds, or the first entry corresponds to the x coordinate. The second entry corresponds to the y-coordinate. Now, we may or may not put labels on the axes or put arrowheads on the axes. However, you are expected to understand what's going on. You should know the significance of the positions. And after all, unnecessary ink on a graphic that does not aid in additional comprehension is often referred to by Tuft as chart junk and should be removed. In some cases, if the actual values of the vector don't even matter that much, we will not even include tick marks and or labels. Here are two examples. So, for example, the vector u may be the vector 1.8, 0.4. The vector v may be negative 0.9, 1.1, and the 0 vector is at the intersection of the axes, which is why it is sometimes called the origin. Now, real 3-dimensional vectors can also be interpreted as points not on the plane, but in 3 space. Generally, again, the axes are labeled x, y, and z, and a 3-dimensional vector is interpreted as a coordinate in this 3 space. Now, the orientation of the positive x, y, and z axes depends on what is called the right-hand rule. Some of you may have seen this in secondary school. The right-hand rule indicates the directions of the positive x, y, and z axes using the index finger to indicate the direction of the positive x-axis. The middle finger points in the direction of the positive y-axis, and the thumb points in the direction of the positive z-axis. So as you can see, the image on the left does indeed follow the right-hand rule, as x and y are relative to each other based on according to the right-hand rule as shown in the image on the right. Alternatively, if you have the thumb pointing in the direction of the positive z-axis and the fingers are initially pointing straight in the direction of the positive x-axis, then curling the fingers will move them towards the direction of the positive y-axis. So once again, we can see that yes, the image of 3 space on the left does indeed follow the right-hand rule. Now, visualizing a point in 3 space can be a little bit more challenging than in 2 space, as it requires a few more visual cues. Here, for example, we see a vector v. Now, where in 3 space is this vector? Well, is it this point on the xz plane? Or is this vector v a point in the yz plane? Or Once again, is it a point in the xy plane? Or is it this point that is in none of the three planes? By adding a few lines, it is possible to visualize approximately where a point in 3 space lies relative to the axes, and this is what we will be using throughout this course. So, following this topic, you have now seen interpretations of two-dimensional vectors as points on the plane. You've seen interpretations of three-dimensional vectors as points in 3 space, and you are aware of the right-hand rule for orientating the axes in 3 space. Here's the references, the acknowledgements, the colophon, and a disclaimer. Cheers!